Hi everyone, today we are going to learn the Pythagorean Theorem. So the Pythagorean Theorem, as you can see, has to do with a triangle and a specific type of triangle, which would be a right triangle. So this is called a right triangle. So a right triangle is a triangle that has a 90-degree angle, and this is what a 90-degree angle looks like. So if you see this little box in the corner of your triangle, you know that it is a right triangle because it has a 90-degree angle. So the Pythagorean theorem, as you can see, has squares, so we'll be using squares and square roots. And it's a formula that helps us find a missing side length of a triangle that is a right triangle. So the formula is a squared plus b squared equals c squared. The only important side that we need to differentiate from the other two is always going to be c. So c is what's called the hypotenuse. It's the longest side of our right triangle, and it's always opposite of our 90-degree angle. So this is the only one that we really need to watch out for because it's on the other side of our equation. A and B are just the other two side lengths, and it doesn't matter which one you call A or B. So we can find a missing side length by using this Pythagorean theorem and solving for either A, B, or C. But please remember that we can only use the Pythagorean theorem with a right triangle, and you can tell by looking for a little box in one of the corners of your triangle. All right, let's try to find these missing legs. Notice they actually both are hypotenuse using the Pythagorean theorem. So one thing I always like to do is I always draw an arrow across from my 90-degree angle, and I label the side C. Now the other two sides, it doesn't matter if I call this A or B or if I switch those two, but this has to be C. So now we'll always write our formula, a squared plus b squared equals c squared, and then we can substitute our values. So I see that a is 9 and b is 12. So we do 9 squared plus 12 squared equals x squared. That's what we're solving for. We know that 9 times 9 is 81, and we know that 12 times 12 is 144. So we get 225 equals x squared. And we know that to undo a square, we take the plus or minus square root of both sides, except this time we only need to do the positive square root only because we're solving for a leg of a triangle, and it's impossible for a triangle to have a negative distance. So this is why we're not including the plus or minus. So 225 is a perfect square. It is the square root of, it is 15 squared, so we have 15 equals x. So using the Pythagorean theorem, we were able to find this missing side length. Let's try one more together. Again, I always start by drawing an arrow across from my 90-degree angle and calling it C. Now the other two, it doesn't matter which one is A and which one is B. So let's write our formula. A squared plus B squared equals C squared, the Pythagorean theorem. Let's substitute for A and B and X as well. 1 times 1 is 1. 1 times 1 is 1. And so we have 2 equals x squared. Again, the way we undo a square is with the square root, but this time we don't need the plus or minus. So we have square root of 2 equals x. So sometimes the length of one of the sides is going to have a square root, and that's totally fine. Simplify it if you can, but if you can't, we just leave it with a square root. Okay, go ahead and pause the video and see if you can use the Pythagorean theorem to find this missing side length. Okay, go ahead and check your work here. Notice that we are solving for C again because it's across from our 90-degree angle. So here's my equation. I substituted. 7 squared is 49, 3 squared is 9, and we take the square root of both sides, so we get x equals the square root of 58. Now 58 is not a perfect square, but you should always check to see if you can simplify. But if you find the prime factors, it's just 2 times 29. And there's no pairs, which means we can't simplify. So this is actually our answer. Okay, we're going to try these last two together, because this time you'll notice that we're not solving for c, we're solving for one of our other side lengths. So again, I'm always going to draw my arrow going across and label this c. In this, it doesn't matter if it's a or b. Either one can be a or b. So then we write our formula, and we substitute. So this time we called a x squared plus 6 squared equals 10 squared. So I was just substituting the values for the variables, and we have x squared plus 36 equals 100. So here we're going to isolate x squared. So I'm going to subtract 36 from both sides. So we get x squared equals 64. And then to clear the square, we take the square root of both sides. So we get x equals 8. Okay, let's try this second example. So again, draw your arrow to find your c value, your hypotenuse. It's always the longest one as well. And let's call this a, and we'll call this b. So write the Pythagorean Theorem. A squared plus b squared equals c squared. We'll do our substitution. So a is x, b is 8, and c is, 21 squared. So 8 squared is 64, and 21 times 21 is 441. So then to finish solving, we're going to subtract 64 from both sides, and we get x squared equals 377. And from here, we can take the square root of both sides, so x equals the square root of 377. And here, square root of 377, it actually can't be simplified, so that is our answer. Okay, last problem. Go ahead and pause the video and give this one a try. Okay, go ahead and check your answer here. Be careful because 10 must be our c value. So here's my formula. Here I substituted for a, b, and c. 9 squared is 81, 10 squared is 100, and then solve for x squared. So I subtract 81 from both sides, and then clear your square by taking the square root of both sides. So x equals the square root of 19. All right, that is all for today's lesson. Thank you so much for watching.